we did that. Molecular compounds. In molecular compounds, as we mentioned, ions are not involved, and I only have nonmetals. And you need to, I'm sorry, memorize these Greek prefixes. 1 is mono, 2 is di, 3 is tri, 4 tetra, etc., etc., etc. We need this. And we're going to use Greek prefixes, and we're going to name the second element. We're going to put the "ide" at the end, just like we did before, but we're going to use Greek prefixes for stuff. So SO2, I recognize as a molecular compound. So this is going to be sulfur. This is going to be oxide, okay, sulfur oxide, but I need to put the subscript as a Greek prefix. Okay, so it's 2, so sulfur dioxide, okay. Nitrogen fluoride, but I have 3 of them, so nitrogen trifluoride. Pretty simple. This is going to be dinitrogen trioxide. Okay, let's look at some examples. This is much simpler, I think. You don't have to do any of those charge balancing and Roman numerals and things like that. Okay, so if I give you this, name it. So as per usual, feel free to pause it and try to do it yourselves. So this is going to be 2 nonmetals, or a metalloid and a nonmetal. So you can write this as silicon tetrachloride. Okay. If I look at P4O10, okay. So here, 10 is deca and 4 is tetra. So this is tetraphosphorus. Decoxide. So I don't write decoxide, I drop the A and I make it decoxide. Okay. So it is a glare, is really obnoxious. Okay, so as that, see, I have more, don't I? Right. So I want you now to write, this may involve ionic. I didn't vet this fully well, even though I made this up. I just did this a few hours ago, so I don't remember. So write the chemical formulas for the following things. So if I give you carbon disulfide, what would this be? So I showed it to you in the slides, but in case you forgot. This is C, this is S, there's 2 of them. There's 2 of them from the di, CS2, okay? What about disilicon hexabromide? Okay, so SIBR, right? So it tells me dihexa. Okay. Dinitrogen pentoxide. You know, it's not pentaoxide, it's pentoxide. I dropped the A. It usually happens with oxides. You drop the A. So if you wrote pentaoxide, I won't care. Whatever. N and O, I have 2 N2s and 5 O's. Okay, that's it. All right. Yeah, cesium sulfide. So this is ionic. So I'm tricking you. Cesium is in group 1A. And this thing, the sulfide ion. So first of all, cesium is CS because it's in group 1A, it's +1. Sulfur is going to be -2. Because it's in group 6. And you do crisscross applesauce, and you get that this is CS2S. That's it. Okay. Barium hydride. Again, it's ionic. Barium is group 2. Okay, so it's going to be Ba +2. Hydrogen is -1. Crisscross again, and I get that this is BaH2. Okay. And then let's look at, okay, I'll do sulfur tetrafluoride. Sulfur tetrafluoride. Last one. Sulfur. Sulfur, S, Tetrafluoride, this tells me that it's molecular too. Done. Tetrafluoride. Okay. That's it. Now, that's molecular compounds. Lastly, and I'm not going to show you any examples. You can go look at the examples in the textbook if you will, and if you want, you can ask questions. Fairly simple. How do we name acids? And we'll get back to it too when we talk about acids and bases. But acids that are just two molecules, or two elements, I'm sorry, they're going to just be hydro something ic acid. So you're going to just fill in the blank there. Okay, so if I have HCl, it would be hydro, well, it's chlorine, so chloric acid. This would be hydrofluoric acid, and this would be hydrosulfuric acid, and this would be hydrocyanic acid. And these are the ones I'm going to see. Acids that involve this junk, these guys, take note if it ends with an 8 or an ite. You see, they all end with an 8 or an ite. So, here. If it ends with an 8, it becomes ic. It becomes with an ite, it becomes us. So chlorate ion becomes chloric acid. Chlorite ion becomes chlorous acid. And the way it works, you just smush an H in the beginning, or whatever number of H's you want to make it into an acid. Acids have H's. Okay, so hopefully that made sense. Let me know if you have any questions.